Okay, so we've just learned a new system. So if we plot a point in a plane, we can give it coordinates r and theta instead of x and y. So instead of the Cartesian coordinate system, we're going to use this new polar system. And remember, r represents that directed distance from the pole to our point. And then theta is that angle counterclockwise from the polar axis to that vector OP. And so those are our new coordinates, r and theta. Well, maybe it would be helpful if we could switch back and forth. Like if we have a point plotted in the plane, maybe we could figure out the x and y coordinates if we have r and theta, or vice versa. So we need to take our two systems and overlay them. So let's set it up so that the pole matches up with the origin, and the polar axis is the same as the positive x-axis. And so now we should be able to convert back and forth between our two systems. So we may want to, it depends on what we have. So if we're given the rectangular coordinates for a point P, we have x and y, we'd like to come up with r and theta in the polar system, and vice versa. Maybe we have the polar coordinates and we want to figure out the rectangular coordinates. All right, so let's start with, what if we have the rectangular coordinates and we want to find the polar coordinates? So once again, r and theta, x and y. So look what this gives us. This gives us a nice right triangle. Now let's say, okay, so we have rectangular. So we have the x and we have the y. We have numbers here for x and y. We want to figure out this side. Well, from geometry, you probably thought of the Pythagorean theorem. X squared plus y squared should equal r squared. So that's how we're going to figure out r, by using our Pythagorean theorem. What about theta? How do we get this angle? Well, remember, we know this number and this number. So this side is opposite of our angle, and this side, this leg, is the adjacent. So which trig function used the opposite leg and the adjacent leg? Oh, that was tangent, wasn't it? So tangent of theta should equal y over x. And then hopefully we can solve that equation for theta. If it's a relationship, a ratio we remember from the unit circle, we'll know what theta is right away. Otherwise, we might have to do inverse tangent of y over x to get theta. And then we'll have to be a little careful with how the inverse tangent worked. More on that later. Okay, what if the other case is true? What if we have r and theta? They give us the polar coordinates for this point. We know that value, we know that angle. We want to find x and y. All right, well, let's focus on the x first. How are we going to find x? Well, we know the angle, x is the adjacent leg, and we have the hypotenuse, we have the r value. Which trig function used the adjacent and the hypotenuse? That was cosine, wasn't it? Cosine of theta equals the adjacent leg, which is x, over the hypotenuse, which is r. And then if I multiply both sides by r, now I have solved for x. And remember, I know a value for r, and I know what theta is, because we have the polar coordinates. So we can figure out x by just doing r times cosine theta. All right, how about the y? Well, y is the opposite leg, so you're probably already a step ahead of me. We know that the sine of theta is equal to the opposite, which is y, over the hypotenuse, which is r. And once again, multiplying both sides by r, now I have a value for y. Y is equal to r sine theta. So now I have my conversions between the two systems. So if you have the x and the y, you should be able to find r theta. If you have the r and the theta, you should be able to convert back and get the x and the y. All right, so let's try a few examples and let's see how you do. All right, I want to convert the point -2 to root 3. From what mode? What is that in? Oh, that's rectangular because I'm converting to polar. So I want to get r and theta, and I have x and y. Now, some people like to draw a picture for this, so that might be a good idea. Where's -2 and 2 root 3? Well, -2 left, 2 root 3 up, so that's somewhere over about here. I'm in the second quadrant. So that might be helpful to know, instead of just jumping into those conversion equations. So if you remember, we can find the r value. So if this is my pole, I'm looking for that value, but I know the two lengths. I know this is -2 and I know this is 2 root 3. So r squared is going to equal -2 squared, I like putting that in parentheses, plus 2 root 3 quantity squared. Remember, -2 times -2, it's positive 4, plus, now what's 2 root 3 times 2 root 3? You multiply the outside numbers and you get 4. You multiply the inside numbers and you get square root of 9, which is 3. So we're going to get r squared is equal to 4 plus 12 is 16. Now what do? Take the square root of both sides. What's the square root of r squared? Absolute value of r. We've talked about that before. The square root of 16, that represents the positive root of 16. So that's just 4. So therefore r is plus or minus 4, but we know that we're taking the positive value for r, so r is just equal to positive 4. Okay, let's find the angle. Well, we know the tangent of the angle, so the tangent of theta should equal the y over the x, so 2 root 3 over -2. That simplifies down to, let's move that away over here a little bit. That simplifies, if I can organize myself here, -√3 over 1. Now that looks familiar. Do you remember from the unit circle when the tangent equals -√3 over 1? Unit circle. Oh, the unit circle. You know, I like thinking of this, if I make my fraction more complicated, if I divide the numerator and denominator by 2, make a little arrow here. So I'm looking to see when the sine is √3 over 2 and the cosine's 1/2, but wait, what about this negative? Well, that's why it was helpful to draw it. I'm in the second quadrant. So I know that the sine is positive in the second quadrant. So I'm looking to see where the sine is √3 over 2 and the cosine is -1/2. And that's the y-coordinate and that's the x-coordinate. So when is the y-coordinate √3 over 2 and the x-coordinate -1/2? Oh, there, 120 degrees or 2 pi over 3. All right, and the problem did say use radians, so theta is equal to 2 pi over 3. And there we go. We figured it out. Now, remember, it says convert from rectangular to polar. My answer actually should be as coordinates. So I'm going to write 4 comma 2 pi over 3 as coordinates. And there's my final answer. All right, let's try another one. You may want to hit pause and try this, and then come back and see how you did. All right, so convert 3, 4 to polar. Let me draw a quick picture. Where's 3, 4? That's in the first quadrant, right? Somewhere over there. All right, so I'm going to use the Pythagorean theorem to find r. R squared equals 3 squared plus 4 squared. Well, that's a Pythagorean triple that I remember. You can simplify that and you're going to get r is equal to 5. How about the angle? Well, we know the tangent of the angle, tangent of theta, is y over x. Now this one I don't remember from the unit circle. I don't think any of those special angles on our unit circle have the tangent equal to 4/3. So what do? Well, we're going to have to use the inverse tangent and grab a calculator, and then we'll have to approximate our answer. Now this says use degrees, so let me make sure that my calculator is in degree mode, and it's not, so I better switch that. And then I'm going to do the inverse tangent, second tangent, 4 divided by 3, and I get approximately, it didn't say how much to round, so I'll round 1 decimal, 53.1 degrees. So theta is approximately 53.1 degrees. So final answer, I had the rectangular. My polar coordinates are 5 comma 53.1 degrees. And there we go. So once you do a couple of these, you get the hang of it. It's pretty easy, pretty straightforward. Why don't you try to hit pause and work on this next one, and then come back and see how you did. Okay, did you try and do this before listening to me? Well, hopefully you did, and I bet I caught a few of you. If you just started writing out the equations, because I am a computer, I will just work out things the way I'm supposed to, then you probably wasted some time. If you did everything correctly, you would have gotten the right answer. But let's think about this for a minute. What if I plotted this? So remember, we have x and y, and we're trying to find r and theta. So if I plot negative 6, 0, where's that? That's over here, right? Okay. How far is that from the pole if we switch our system? Isn't that 6 units away from the pole? So r is equal to 6. And then what's this angle? Well, that's 180 degrees, or pi radians. Said use radians. So pi. And we're done. So the conversion is 6 comma pi. Are you a little mad at yourself because you started working through r squared equals x squared plus y squared, plus 0 squared, and then tangent of theta equals y over x, which is 0 over negative 6. Well, you will get those answers, 6 comma pi, but you're spending too much time on that. So what you have to remember is math is not, I just memorize steps to problems that I've seen before. Math is I understand the concepts, and then I can apply all the concepts to different problems, and maybe some of them I haven't seen before. All right, I'll get off the soapbox. Convert 5 comma pi over 6 to rectangular. Oh, now wait a minute. Now we have polar. We have the r and the theta, and they want us to find the rectangular, which is the x and the y. So wait, if I do a quick graph of this, let me kind of ballpark. There's my pole, there's my polar axis. Pi over 6 is what, 30 degrees? So pi, let's say it's somewhere over about here. Right, so there's my point. So I know I'm in the first quadrant. I know x and y should both be positive. I also realize that x is going to be bigger than y. Okay, so if you wanted to make a right triangle out of this to help you, if you're a visual learner and this is 30 degrees here, and this is x and this is y, one thing you might think of, well, you could think of the conversion equations and say, well, x should equal 5 times the cosine of 30 degrees. Okay, and then y is going to equal 5 times the sine of 30 degrees. Both of those values we know. What's the cosine of 30 degrees? Oh, that's the square root of 3 over 2. So we're going to get 5 root 3 over 2 for our x-coordinate. And then what's the sine of 30 degrees? Well, that was 1/2 from our unit circle. So y is going to equal 5 over 2. So final answer, the x-coordinate is 5 root 3 over 2, and the y-coordinate is 5/2. Well, that was pretty easy. And yes, I do think it's easier to convert polar to rectangular. But you might have also recognized, let's draw a little arrow here, that this is one of those special right triangles, isn't it? 30, 60, 90. And the side opposite 30 is half the hypotenuse. Oh, so y is half of 5. And then the longer leg, the one that's across from 60, is the shorter leg times the square root of 3. So 5/2 times the square root of 3. So we could have not done these equations, and from what we've learned back in our special right triangles in geometry class, figured that out. All right, let's try one more. Once again, you might want to pause, try this one on your own, and then come and check it. Okay, so step 1, I always like to visualize. So here's my pole, here's my polar axis. Let me kind of put my x and y axis on top of this to help me out. And so where's pi over 4? Pi over 4 is right around here, except it's -4, so I'm not going 4 units in that direction. I'm actually going 4 units in the opposite direction because it's a negative r value. So I'm down here in the third quadrant. I also realized that the pi over 4 coordinates, the x and y, have the same, give or take a plus minus, because sine and cosine of pi over 4 are the same. So I know that my coordinates will both be the same on this one as well, won't they? So x is going to equal r, which is negative 4, times the cosine of pi over 4. And what was the cosine of pi over 4? Oh, that's the square root of 2 over 2. And then I could do some reducing with the 4 and the 2, and I'll get negative 2 root 2 over 1, or just negative 2 root 2. Now, because I thought ahead of time, I know that the y value is going to be the same as the x value, and it's in the third quadrant, so it's also negative. So I have my two coordinates, and I'm done. Negative 2 root 2, comma, negative 2 root 2. And there's your answer. Okay. But if you don't believe me, and you went and worked it out, you get negative 4 times the sine of pi over 4, and then you'd realize, oh, that's the same. That's negative 4 times root 2 over 2. And I got that answer. Okay, so hopefully now you understand how to convert back and forth between our two systems, our rectangular system and our polar system. And so given coordinates in one, you should be able to come up with the coordinates in the other.